glucose stored in our body is called glycogen, and we have some in our liver and we have some in our muscle, but it's not a lot. Really, if we stop eating, we will run through that stored glucose in a matter of 24 to 48 hours.
As we age, our brains don't process glucose as efficiently. So even if you have enough glucose in the brain, your brain is not able to utilize the glucose that's available to it effectively. So it has low energy, put simply. And the ketones, if it has access to ketones, it'll process those first.
When you don't have enough calories and your body needs energy, it'll go and break down the fat from our body stores and release it so that the body can use that. But the brain is special, it's protected. It's not as easy to get to. And the brain cannot efficiently use these fatty acid molecules for energy. Fatty acids are broken down into ketones, which are water soluble, and they're able to cross something called the blood-brain barrier, which means that they can get into the brain and be a fuel for the neurons and the supporting cells in our brain. So about 20% of the energy that we use on a daily basis goes to fuel our brain, even though our brain is only about 2% of our body weight. We, for a long time, kind of had this conversation, especially in the academic community, that glucose was really the only energy for the brain. It's the only thing that the brain can use. And it's just not true. We know, and we have known for a long time, that ketones are very efficient energy substrates for the brain.
So in the future, I think this will be better appreciated. And there's very important research going on now about this exact subject. How high would the ketone level have to be to replace enough of the glucose that's not being used because of aging to make a difference in memory?